Great. So to just wrap everything up, because we were coding this GPT model, let's just apply it to generate text. We actually we okay. So let me write that generate text here. How do we use this model to generate text? How does it generate text? That is the question that we are just answering this video. And as you can see, it is the pretty much the last video. Technically it's not the last video of the chapter, but it is the last video with concepts. In the next video, we just summarize the chapter and that's it. So for generating text, we know that LLMs, they generate text one word at a time. So they do one word, or uh, to be very sure, one word or token at a time. And they do this next word prediction. It's also called greedy. The way we're going to apply it is it's called greedy decoding. We're going to apply greedy decoding, where it will take the one with the maximum probability. So let's see what that means. Our first iteration, imagine our first iteration, we have something like hello, I am. That's what we have. In the first iteration, it's going to predict a word. And the word that it's going to predict probably is going to be air. That is the prediction. After it has predicted that, it then goes back and then does a second iteration. And in the second iteration, it will take that predicted air and then embed it and put it into the input. So yeah, this is input context. So this is our input context in that iteration, and this is our predicted word. So now in our second iteration, that predicted token or word becomes part of our input context that then goes into the model again. And when it goes into the model, we're going to predict, maybe it's going to be model. That's the um, next prediction, right? And then it then creates the third iteration, which is going to be hello, I am a model. It's not hello, I'm a model. And after it does that, maybe it predicts ready as the new word. It keeps doing this until it gets, let's just say, the sixth iteration, where it will now have hello, I am a model ready to help. And then it's done. And then it's done predicting. So it does that one word at a time. So as you can see, at each iteration, the input context grows, allowing the model to generate coherent and contextual appropriate text. By the sixth iteration, we have a good text that is coherent, makes sense, and is just finished. We know that we have our GPT model, right? It outputs tensors. It's outputting tensors that have this shape. It was batch size. It has the shape batch size. Then number of tokens. And then the last one is the vocab size. So that is the shape of the tensors that it returns, right? So now the process is, how do we now go from those logits or those tensors into words? And that is the aim of this video. So let's see what the steps are. It's going to be a couple of steps. So let's see what the steps are. So imagine we had this context already. Hello, I, hello, comma, I am. That's what we have. Hello, I am, right? When they are embedded and encoded and all of that good stuff, 15496 could be the. Oh, yeah, let's just deal with token IDs, because token IDs, they are tokenized 314, because they're tokenized outside the GPT model, right? So these are the tokens, the token IDs. So those are the token IDs. The first step is just encoding them into token IDs like we did here. So this is step number one. And then they are passed into the GPT model. You remember the GPT model now does the embedding, the positional embedding, all of that stuff, processes it, multi-head attention, layer normalizations, dropouts, all of those things that are there inside the GPT model. And then the GPT model, we saw that it outputs these, the tensors with that, the shape that we saw just now. So let's just write them here for one. And then it will be 1.2199 dot 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 minus 0.3599, and then 1.0446, then 0.0020, and then we'll have our minus 0.4929, and then it'll go all the way up to 0. Let's just say 0.6093. So this is the output. So the second stage is the GPT model. It will return this matrix, which consists of these four vectors or rows, because we had four tokens here that went into the model, and it will have the dimension is 50,257, because that is our vocabulary size, right? That is our vocabulary size. Nice. So the shape is obviously going to be 1,452,57. One, because we just have one batch with four tokens and 5,000, 50,257 each. Now that we have, we will extract the last vector. That's what we're going to extract. We're going to extract this last vector here as the third step. So we extract this last vector because it corresponds to the next token that the GPT model is supposed to generate. It's supposed to generate. So let's see. We extract that as the third step. We have our last vector there. It is minus 0.4929 dot 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 dot. Let's just put something there. 2.4812 dot 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 minus 0.6093, like that. That is, so we have extracted it as our third step. Our fourth step now is we will apply softmax. We'll apply softmax, which calculates probabilities and then makes sure that everything adds up to 1. So it then converts these into 0001, and then all the way up to 0.0200, and then goes all the way to 0.0001. That's what softmax does. So that is our fourth step. Our fourth step here converts those logits into probability distribution using our softmax. And then our fifth step is we identify the one with the largest probability, or the one with the largest number. It is this one here. So our fifth step is identifying where the largest number is in this index, in this vector. This is index number 1, index number 0. This is index number 50,257. So if we identify where the maximum is, we just extract that index. And when we extract that index, we'll see maybe the index is 257. Because of how our vocabulary is done, we know that this is the token ID of the one that is the highest probability. And so we can now just go to the vocabulary and then grab what that ID is. What this ID is representing A in our vocabulary. That's it. Now we've extracted the next word to be predicted. And what we then do is we then take this and we add it to our input. And then we add that A, which is our 257 token ID. And then we repeat this process. We repeat the process until we are done, until we reach that end of token or end of sequence end of sequence token or whatever our stopping criteria will be. That's pretty much what we're going to do. So let's see how this happens in code. So let's switch quickly to our Chrome. So in our Chrome, we are going to do this function called generate text, which is just simple. It's simple because right now the way we are generating text, we are using that greedy decoding, where we are taking the maximum, the softmax, we take the maximum. We'll see where it happens then. So now for whatever range, we do not know what the range is going to be, but it's going to be oh no, we know what our range is going to be, our max new tokens. What are the max new tokens that we want to generate, or the iterations that we are going to do? And here, so we are just getting now the logits. We now apply the model, our model that we already had. Remember, we had our model that we created here. We have a model that we created here when we instantiated this object of the GPT model. So we already have a model ready to be used. So we use it here. And then, and that's it. So when we apply now, we have our logits. We have our logits. So now that we have our logits there, um, now that we have our logits there, we then just we focus on only the last logit. We do not want to focus on all the other ones. We just want the last logit, because that is the way where it's going to be our that's the one that's going to have our last token that we want. So that's why we are using -1. -1 just gets the last element. So here we're saying the -1 with all its dimensions, please bring it back. That's it. Now that we have that, we will then apply to get our probabilities, apply softmax to get our probabilities, apply to our logits, and that's it. Apply our logits. Now we know the probabilities. We'll then use argmax to get which argument is the maximum in that list, in that array of probabilities. And then we now have that index. So now that we have that index, we then add that index to our indexes. So you see our index, we had our indexes. Our indexes were going to be what what our input was, what our input was. So onto those, we just now concatenate and add our index that we have predicted here, and we return the indexes. So those who have the token IDs, we just have the token IDs, right? So why did we say this is just as simple? Is because in the next chapter we are going to discuss other ways of actually calculating this part here, this next index. Because here we are just doing something very simple. We are getting the maximum probability. But sometimes you want variability, you want it to be variable. That's where we start talking about temperature, top K, and all of those that we are going to see in the next chapter. But for now, we're keeping it very, very simple. So let's start with this start take context here called hello I am. We encode it using our tokenizer that we saw, that's coming from GPT-2. It's actually coming from TikToken, but in TikToken we are picking up the GPT-2 encoder, the one that worked for GPT-2. We have our encoded text now. So these are our IDs, as we saw when we're writing it. These are our IDs. Now that we have our encoded, we are going to the shape is just going to be 1 and 4. That's just a shape that we're printing. We are putting our model as model.eval. It sets our model to be, it disables things like dropout and all of that, because we had in our transformer block, we had dropouts and all of those things. When we put it into eval, it means we're not training the model. The dropout is only used during training. So now we are using the model for inference. So we have to do the model.eval. We put it into evaluation mode, where we can now just apply the model because we would have trained it, right? Cool. So now that it's in evaluation mode, let's now just generate simple text. We give it that model. We give it the encoded text, encoded tensor, which is our encoded tensor here that we had. And then we max new tokens. We want to generate 6 new tokens. So it will iterate 6 times. And then our context size is just our context length that we have from our config. So let's look at our output. So our output is now 15154611314. This is our input. And it generated this, put it back into the model, added it to the input sequence. We had a new input sequence, generated this, concatenated it, and then generated this, concatenated the input, generated this, concatenated the input so that this becomes the input, so that this becomes the new input in that run, and then generated this last one. So that's what we, so our output is now length 10 because of course we had our context, our initial context we had 4, plus we said here we want to have 6 new tokens. Now that we've done that, let's now decode. Let's use the tokenizer to decode what these tokens are. So we are going to decode these tokens, token IDs. Now what we have, the decoded text is hello, I am whatever that's going to be. Mm. It's not saying hello, I'm a model ready to help. Why? Because this model has not been trained. We just it instantiated. You remember even parts like if we are to scroll up and look at our multi-head attention, our queries here, our QKV models, they were just instantiated randomly. Many things in this model they're just instantiated randomly. They not their weights have not been trained and all of that. We have not trained this model at all. So right now it is spitting some text, but it is gibberish because it has not been trained. And that will be the focus of the next chapter, training this GPT model so that it now outputs hopefully better text. So in the next video, let's just summarize what we learned in this chapter.